question is, what are this quadratic? We know it's a quadratic because it's to the second power. Next we know, but to the third power, fifth power, it does get more complex. Okay? And so you may remember, what was our first step when we're trying to solve a quadratic? Put it in a standard form. That means you're going to move everything to one side and put it in order from biggest to smallest. Okay? And so I'm going to bring my negative 6 over by adding 6 to both sides. Right? So it's going to be x squared minus 5x plus 6 equals 0. You can either think of it as adding 6 to both sides, which crosses out negative 6 plus 6. The way I like to think about it is if I move something to the other side, it changes something. Okay? So that was our first step. First step, put in the standard form, right? Our second step, we're going to factor that. Now when we factor, there are 4 different cases. One, does it have a GCF? You should always ask yourself that. Does it? GCF? No. What kind of quadratic is this? Is it a binomial or trinomial? Trinomial, right? Now, is it A is 1 or not 1? A is 1. And so when A is 1, trinomial, quadratic, those are the easy ones. At least I think so. So, two numbers that multiply to 6, but add to negative 5, those two numbers are what?
6 and 1. But 6 is negative.
6 plus 1 is 7 though. And 6 plus negative 1 is 5, so that won't work.
3,
Huh?
2, 3, 2 is
Negative 2, negative 3?
yeah.
Yeah? So negative 2 times negative 3 is plus 6. Negative 2 plus negative 3 is negative 5. Now, because A is 1, these are fast, right? Now, if this had not been 1, then I'd break negative 5x into negative 2x minus 3x, split it in half, factor to left, factor to right. That's a lot of work. But this one's going to be x minus 2 and then x minus 3 and then equals 0. Okay? So, I factored it, and then you're going to set each factor equal to 0 and solve. The reason why is because when you multiply two quantities, so you got x minus 2 here, you have x minus 3 here. When you multiply two numbers, the only way to get 0 as a product is if one of them is 0. Like 3 times what is 0? There's only one solution, 0. Or if I say what times 3 is 0, there's only one number that works in 0. You have to have one of them to be 0, or they could both be 0. So your next step is to set both of these factors, linear factors, because they're to the first power. You're going to set both of those equal to 0. Solve them for x. I'm going to add 2 to both sides. Alright? So x equals 2. And then also add 3 to both sides. X equals 0 plus 3 is 3. So those are my two solutions. Right. Yes?
If we know how to think that x equals 2, we have to do x minus 2.
No. The way I like to think about it is if that's x minus 2, then your solution is x equals 2. If it's x minus 3, then it's x equals 3. If it's x plus 3, then it's x equals negative 3, right? No. So what this means is on my graph, on a really, really sketchy, not very pretty graph, that here at 2, that's my up because the leading coefficient is positive. And it's going to have the vertex down here somewhere. And I taught you how to find that vertex. Graph means. So if you type this in your calculator, well, you'd have to put it like this, here and here. Now to be a solution, what that also means, up here, I'm going to get negative, and if I plug 3 up here, I'm going to get negative 6. So like 2 squared is 4, right? And minus 5 times 2 would be 10. What's 4 minus 10? Negative 6. And then 3 squared is 9. 9 minus 15 is also negative 6. So because this, you should have two solutions. So either you're going to get distinct solution equals 2 twice, or x equals 3 twice. And I'll show you this Thursday. These could be imaginary solutions. Okay?